Hello, sleepy thinkers, and welcome to Sleepy Science Teller, where we wander softly through the wonders of the universe and drift together into quiet curiosity and rest. Tonight, let's close our eyes and imagine something truly mysterious. What if our Earth were suddenly pulled into a black hole? Black holes are among the most powerful and yet most peaceful mysteries in all of space. They are regions where gravity grows so strong that even light itself cannot escape. To fall toward one is to travel toward the edge of time and to witness the deepest laws of nature unfold in slow, silent beauty. Before we begin our journey, take a gentle moment and share in the comments where in the world you are listening from and what time it is right now. Are you watching under the stars or drifting into sleep in the quiet of your room? If you enjoy gentle journeys like this one, please take a moment to like this video and subscribe. It helps our little universe of calm science continue to grow. Now let's begin our slow fall into the mystery of a black hole. Imagine a star far larger than our sun, burning quietly in the deep silence of the universe. For millions upon millions of years, its light has been crossing the emptiness of space, touching distant worlds, warming strange planets we will never see. Every second, it breathes energy into the cosmos, its nuclear heart fusing atoms together, turning tiny hydrogen into radiant light. But as all things in the universe must do, the star begins to change. Its fuel, the simple hydrogen that kept it alive, begins to run low, like a candle reaching the end of its wax. The star starts to tremble under its own immense weight. You can imagine it now, its brilliant surface cooling slightly, its outer layers swelling, turning red and vast, becoming what astronomers call a red supergiant. Inside, its core becomes restless. Pressures rise, and atoms are crushed closer than ever before. In this quiet cosmic furnace, a final struggle begins, gravity pulling inward and nuclear fire pushing outward. Two titans locked in balance, until suddenly the fire fades, the outward push ends, and gravity wins. In a heartbeat, the star collapses inward on itself. Its core implodes, faster than sound, faster than light can react. This moment, though unimaginably violent, happens in silence because space has no air to carry a sound. And then, in that instant of collapse, the heart of the star becomes infinitely dense, a place where all matter, all light, all information is pulled inward towards something we call a black hole. The universe, it seems, is always recycling. Even in endings, it creates new mysteries. Scientists believe that when a star like this collapses, the gravitational force becomes so intense that not even light, the fastest traveler in existence, can escape. And because no light returns, we cannot see it directly. We only see what it does, how it bends nearby starlight, how it pulls on passing gas clouds, how it makes time itself behave strangely. If you could stand near such a place, though you never truly could, it would not look like an object at all, but a dark circle, a hollow absence surrounded by a glowing halo, where light is bent into an eternal curve. This dark region, this quiet well of gravity, is the black hole's event horizon, the edge between the known and the unknowable. For every black hole, this horizon marks the border where reality begins to twist. Inside it, time, space, and even cause and effect lose their normal meanings. To approach it is to drift toward a place where physics, as we know it, stops making sense. Yet, despite its strange power, a black hole is not a monster, not a destroyer, but a natural consequence of a universe's own elegance. It is the ultimate expression of gravity, a region where matter has folded itself completely into silence. And so, the story of every black hole begins with the death of a star, a beautiful ending that gives birth to a quiet mystery. Now, let's drift a little closer and imagine what it would feel like to approach one. The space around a black hole is not truly empty. It is surrounded by the remnants of what it has touched, clouds of gas, dust, and forgotten fragments of ancient stars. As these remnants fall toward the black hole, they spin faster and faster, forming a brilliant, swirling disk of light. This glowing disk, called an accretion disk, is one of the most mesmerizing sights in the universe. Imagine rivers of fire spiraling silently through space as matter rubs against itself, heating to millions of degrees. It is a cosmic whirlpool, a silent, eternal storm, and at its center lies a point of infinite density, a singularity. It is here that all known laws of physics begin to break down. Einstein's theory of general relativity tells us that gravity is not a force pulling downward, but rather a gentle bending of the fabric of space and time. Mass tells space how to curve, and space tells matter how to move. It's a dance of geometry, a cosmic choreography that shapes everything, from falling apples to orbiting planets to collapsing stars. But in a black hole, this dance spirals beyond comprehension. The curvature of space grows infinite. All directions lead inward. There is no up, no down, no out. Everything falls forever. Astronomers can't see inside, but they can measure what happens nearby. They can watch stars orbiting invisible centers, and they can detect X-rays, faint whispers of energy, as matter disappears beyond the edge. In 2019, humanity saw its first real image of a black hole in a distant galaxy called Messier 87. It looked like a glowing ring surrounding a dark core. That dark center was not the hole itself, but the shadow it cast, the point where light vanished completely. It was one of the quietest, yet most powerful discoveries of all time, a photograph of emptiness that proved the universe was full of wonder. Now imagine floating in a spacecraft, far from any star, drifting near one of these cosmic voids. You wouldn't hear anything. You wouldn't feel the pull. Immediately, the stars behind you would begin to distort, stretching and bending, their light curving around the invisible center. You would see the warping of space itself, and then, slowly, you would begin to fall, not downward, but inward, into a deep, silent well that seems endless. The feeling would be calm. There would be no sudden jolt, no violent tug, just a steady drift, like falling asleep and dreaming of eternity. You see, the universe is full of opposites, creation and destruction, light and darkness, motion and stillness. But black holes remind us that these opposites are not enemies. They are two sides of the same pattern. A black hole doesn't destroy matter. It transforms it. It takes the scattered pieces of stars and folds them back into the geometry of space. Some physicists even believe that every black hole could be the seed of something new, a doorway, a hidden passage into another universe. The equations of relativity suggest that what falls into a black hole might emerge elsewhere through what's called a white hole, a region where matter can only escape, not enter. It's purely theoretical, but beautifully poetic. If that's true, then perhaps black holes aren't tombs, but tunnels, gateways through which the universe recycles itself. And even if that's not the case, their existence alone teaches us something profound about the limits of our knowledge. We humans, so small in this vast expanse, have looked into the deepest dark and dared to ask what lies within it. We built telescopes. We sent probes. We wrote equations that touch infinity. And in doing so, we discovered not chaos, but order. Black holes may seem terrifying, but they are not. They are calm, constant, and perfectly balanced. They remind us that even the universe's greatest powers operate in harmony. And so, when we speak of black holes, we are not really speaking of destruction, but of balance. The universe's way of keeping its own quiet rhythm. They are the cosmic punctuation marks, pauses in the story of stars, that let the next chapter begin. So when you imagine one, don't think of it as an end, but as a soft return, a reminder that even in the deepest darkness, the universe is still at peace. Gravity is the most patient sculptor in the universe. It works slowly, quietly, without sound, and yet, over time, it shapes everything we know. Every planet that circles the sun, every moon that follows its mother world, every grain of dust that drifts in the blackness of space, is following a silent thread, woven by gravity's invisible hand. On Earth, we feel it every moment, a gentle tug beneath our feet, keeping oceans in their basins, holding our atmosphere close, anchoring our lives to the spinning world. It feels constant, reliable, as though gravity were simply down. But in truth, gravity is not a direction. It is a relationship. It's the way mass and space speak to each other, an intimate conversation between matter and geometry. Einstein showed us this when he told the world that space itself can bend, that time can stretch, and that gravity isn't so much a force as it is the shape of the universe's fabric. Imagine a soft sheet stretched tight and a heavy ball placed in its center. The fabric curves, and smaller marbles placed nearby roll gently toward the dip. They are not pulled by invisible strings. They are simply following the natural curve of space itself. Now imagine increasing that weight until the sheet curves deeper and deeper, and finally tears open into a bottomless pit. That is what happens when gravity becomes infinite. A black hole is that final curve, the deepest possible valley in the fabric of space and time. It is the point at which gravity's whisper becomes a silence so absolute that even light cannot escape. But what makes gravity so powerful here? What allows it to reach such extremes? The answer lies in density. When a massive star collapses, all of its mass, sometimes more than 1,000,000 Earths, is compressed into a point smaller than an atom. Imagine all the mountains, oceans, and cities of Earth squeezed into a single grain of dust. Now multiply that by 1,000,000,000. That density creates a gravitational field so intense that the usual laws of physics simply give up. They cannot describe what happens inside. Space folds, time slows, and the curvature becomes infinite. Scientists call this the singularity, a place where the equations stop working. And even though we cannot see it, we know it is there because of how it shapes the world around it. Gravity, in this form, is no longer the gentle tug we feel on Earth. It is the quiet fall of reality itself, toward its own center. But even here, in the idea of infinity, there is beauty. Gravity, you see, does not destroy, it gathers. It collects scattered matter and brings it together as though the universe were tidying up after itself. It is not chaos. It is structure, the silent pull that gives everything form, from the smallest pebble to the brightest galaxy. Let's travel deeper into that curve of space and time. Imagine, if you will, a spaceship hovering near the edge of a black hole. Not too close, just far enough that its engines can hold it steady. Out the window, you would see the stars behind you bending, their light curling around an invisible center. You would see your own reflection, not once, but many times. As light wraps fully around the black hole and returns, it would be like looking into a mirrored maze, a tunnel of distorted light, stretching forever. The space around you would feel stretched, as though distances were growing longer, time itself running slower. And that is not imagination, it's physics. Einstein predicted it perfectly. Where gravity grows strong, time runs slow. If you could watch a clock ticking near a black hole, you'd see it slow and slow until, to you, it almost stops. Yet, to someone near that clock, time would still feel normal. Their heartbeat, their breathing, their thoughts would all seem the same. But from your distant perspective, they would be frozen, trapped on the edge of forever. This effect, called gravitational time dilation, isn't just theory. We can measure here on Earth. Clocks placed on mountaintops run ever so slightly faster than those at sea level because they are farther from Earth's gravity. The difference is tiny, fractions of a second over years, but it proves a profound truth. Time itself is flexible. Now, stretch that effect to the extreme, and you begin to understand the black hole's infinite pull. In that region, space curves so steeply that all possible paths led inward. There is no direction that leads away. Even light, which normally follows the fastest, straightest route, finds itself bent into endless circles. And so the black hole becomes invisible, not because it hides, but because light cannot leave its embrace. The boundary of that invisibility is called the event horizon. It is not a physical surface, but a region of no return, the place where space itself is falling inward faster than light can travel outward. From far away, you might see the last traces of matter as it spirals in, glowing brighter, reddening, stretching until it fades into darkness. To you, it would never truly cross the horizon. It would simply slow and vanish. But to the falling matter itself, the story is different. It continues, crossing the boundary without noticing and falling freely, deeper and deeper into the curved heart of the universe. Gravity, in this moment, is not felt as pain or tearing. It feels like free fall, like floating in an endless sky, where every direction leads inward. A black hole is, therefore, the perfect embodiment of gravity's will. It is not loud. It does not rage or burn. It simply pulls, endlessly, silently, completely. Now, let's pause for a moment and think of what infinite really means. We use the word often. Infinity of stars, infinite sky, infinite dreams. But in physics, it has a quiet, specific meaning. It means without limit, a place where numbers stretch forever, where measurement loses its meaning. At the singularity of a black hole, gravity becomes infinite. It does not simply grow stronger. It transcends every boundary we know, and in doing so, it exposes the edges of our understanding. Scientists have tried for decades to describe this region precisely. They've used the language of mathematics. Einstein's relativity on one side, quantum mechanics on the other, but the two stories never quite fit. One speaks of smooth, continuous space, the other of discrete, jittering particles. At the heart of a black hole, these two tales collide. This is why physicists seek a theory of everything, a single idea that unites the cosmic and the quantum, that explains not only how the universe moves, but why it holds together. Black holes, strange as they seem, are our laboratories for this quest. They are places where time, matter, and energy all meet their ultimate limits, and through studying them, we may someday glimpse the deeper laws of creation itself. But even without that final theory, we already know something profound. Gravity is not the enemy of light. It is its sculptor. It shapes galaxies into spirals, stars into orbits, planets into worlds where life can bloom. Without gravity, there would be no sun, no earth, no you, no me, only endless drifting dust. So when gravity grows infinite, when it folds itself into a black hole, it is not a failure. It is the universe completing its cycle. In its silence, it carries a memory of stars. In its darkness, it holds the blueprint of beginnings. Perhaps, in some deeper sense, gravity's infinity is not an end, but a doorway, a quiet path back to creation. And maybe that's why even the darkest places in the cosmos still fill us with awe and peace, because somewhere beyond the limits of what we can see, the universe continues to breathe. Imagine a quiet evening on Earth. The air is still, soft with the fading warmth of day. Somewhere, waves are folding gently against the shore, and the last rays of sunlight are melting into twilight. Everything feels normal. The stars begin to appear, one by one, and the moon drifts into its familiar orbit. Nothing seems different, but far, far away, something has already begun. Somewhere in the distant galaxy, a black hole is drifting closer. Not fast, not loud, just gliding silently through space. Pulled by the unseen tides of the Milky Way, black holes are not hunters. They don't chase planets or swallow stars at random. They move like any other celestial body, following the quiet currents of gravity, spiraling through space in slow, majestic arcs. And yet, if one were ever to come near us, the first signs would be subtle, almost unnoticeable. Tiny variations in the orbits of distant objects, a slow wobble in the paths of asteroids, a faint distortion in the light from the stars beyond. At first, astronomers would be puzzled. Their instruments might detect small shifts in gravitational pull, a disturbance that doesn't quite fit our solar system's balance. Telescopes would track distant stars and notice their light bending ever so slightly, as though an invisible lens were drifting across the sky. That lens would be gravity itself, the signature of something massive but unseen. As it moved closer, the first real clue would come not from sight, but from starlight. Photons, those tiny packets of light, would begin to curve in strange arcs. The stars behind the black hole would seem to shimmer as if the universe were looking at itself through water. People on Earth might not notice at first. Life would continue. Days would pass. Seasons would change. Oceans would rise and fall. But scientists would begin to whisper, something is shifting. Something enormous is nearby. And then, perhaps one night, astronomers would turn their telescopes toward a patch of sky where no stars should be and find, instead, a faint ring of light, a perfect glowing circle, like a halo around emptiness. That ring will be the first visible sign that Earth's long journey had begun. It is called an Einstein ring, a result of gravitational lensing, where light from distant stars is bent perfectly around an invisible center. It would be hauntingly beautiful, a circle of distorted starlight, delicate and golden, surrounding a darkness that no one could name. The world would watch in awe. For the first time, we would see the universe not as background, but as something alive, something that breathes and moves and pulls us gently along. Now, imagine weeks or months later. The black hole has drawn closer. Still, millions of kilometers away, but close enough that its gravity has begun to stretch the fabric of our solar system. At first, only the most sensitive instruments would notice. The orbits of the outer planets, Neptune, Uranus, Pluto, would begin to drift, slightly elongated, like dancers adjusting to a new rhythm. Then, slowly, the pattern would ripple inward. Saturn's rings would begin to warp. Jupiter's moons would twist in their paths. And the balance of our cosmic neighborhood would start to tremble. But here on Earth, it would still be calm. Skies would look normal. Clouds would move lazily. Waves would still rise and break in familiar patterns. The pull of the black hole would not yet be something we could feel. Gravity, after all, works quietly. It does not yank or snap. It persuades. It whispers until everything listens. As the black hole's influence deepened, time itself would begin to stretch, not in a way we'd sense directly, but in subtle differences between regions of the solar system. Clocks in deep space would begin to drift out of sync with clocks on Earth, atomic clocks, so precise they lose only a billionth of a second in a year, would begin to disagree. Time, the very fabric of experience, would start to ripple. Scientists would see it first. They would issue calm, careful messages, trying to explain what was happening. Gravity was being rewritten, not by any catastrophe, but by the presence of a neighbor, so massive that even light obeyed its command. Satellites orbiting Earth would start to drift. Their paths would need constant correction. The moon might wobble slightly, its face turning at angles unseen before, and through telescopes, the sun's light would begin to waver. The black hole's gravity would begin bending, not only starlight, but the path of the light from our own sun. It would seem to shimmer differently, slightly brighter, slightly redder, depending on the time of day and the angle from which you watched. It would be as if the heavens themselves were breathing slowly in and out. For ordinary people, the days would continue. But perhaps a quiet sense of awe would settle in. Nights would feel deeper. Stars would seem to move differently. And even though we would not yet be in danger, a new awareness would awaken that our world, so familiar and warm, was beginning to travel into the unknown. And then there would come a moment of pure stillness. No explosions, no apocalyptic noise, just a calm, too perfect to be natural. The black hole's pull would reach the inner solar system, it would begin to align the motions of planets in ways never seen before. Each orbit slightly stretched, each rotation a little slower. It would be as though time itself had taken a deep breath and held it. On Earth, the skies might begin to behave strangely. Sunsets could linger longer, the light bending through an ever-shifting atmosphere. Shadows would seem deeper, and stars might rise earlier in the evening. Astronomers would be watching closely now, every telescope pointed upward, every observatory recording data. They would measure gravitational waves, tiny ripples in space-time, passing through Earth like invisible tides. People might begin to see things they couldn't explain. The auroras would dance in new colors, brighter greens, deeper purples, as magnetic fields reacted to the distortions around them. Radio signals might flicker, GPS systems might drift, and deep space probes would send back strange, distorted messages. And yet, in the middle of all this change, the world would remain breathtakingly calm. No great disasters, no violent storms, just stillness, as though nature itself had paused to listen to the deep hum of the universe. Perhaps birds would begin to migrate differently. Perhaps ocean tides would subtly shift. Perhaps even human hearts, in their quiet biological rhythm, would somehow sense the slow bending of time. Then one night, when the air was clear and cool, the sky would reveal something extraordinary. A black patch where no stars shone, not empty, but impossibly dark, a darkness that seemed alive. Around it, a faint circular glow, light from distant stars, bent into a perfect ring. It would hang in the night sky, like a silent halo, a window into the fabric of reality itself. And humanity would know the journey had begun. Our planet, our home, was moving, slowly, gently, toward the greatest mystery the universe had ever made. And though fear might stir in some, there would also be wonder, because to fall toward a black hole is not be destroyed, but to be invited into the deepest secret of existence. For even as gravity grows stronger, even as time begins to stretch, the universe remains calm, serene, almost loving. This is the calm before the pull, the hush before the stars begin to move, the moment when everything, including Earth itself, listens to the silence of infinity. It starts almost imperceptibly, a subtle shimmer, a faint distortion in the night sky. The constellations, once familiar, begin to look slightly out of place. Stars that have guided sailors, dreamers, and storytellers for millennia seem to waver, like distant candles seen through rippling water. At first, no one believes their eyes. They blink, they adjust their telescopes, they check their instruments again. But the data is clear. The sky itself is bending. This is the black hole's quiet touch. Gravity so intense that even light, the fastest traveler in the universe, cannot move in straight lines anymore. Photons, those tiny, tireless particles of light, find their paths warped, their trajectories curved around the invisible mass. To them, the universe is no longer flat. It is a flowing sea, with currents of gravity swirling through it. The closer the black hole comes, the more dramatic these effects become. Distant stars appear doubled, their images stretched into luminous arcs, sometimes forming near-perfect rings of light around the place where the black hole hides. Astronomers call this gravitational lensing, but from Earth, It looks almost magical. Imagine standing beneath a deep indigo sky where the Milky Way no longer flows in a smooth river of light, but ripples softly as though someone were stirring it with invisible hands. Some stars flicker brighter for a moment, others fade. The night feels alive, shifting, breathing, bending. It would be beautiful and haunting. People would gather outside at night, trying to capture it with cameras. But no photograph could truly hold it. The distortion would move too subtly, too fluidly, for any lens to capture. It would be like watching a dream, drifting through space. Scientists, meanwhile, would be working tirelessly. Their computers would hum with calculations. Their simulations would glow with data, showing how light curves, how time slows, how matter trembles at the edge of such immense gravity. And as they watched, they would begin to see that the distortions in light were not just optical illusions. They were signs, indications of something deeper. Because wherever light bends, time bends with it. And wherever time bends, reality itself begins to change. Time, that invisible current we all float within. We measure it with clocks, with the rising of the sun, the beating of our hearts. But near a black hole, time refuses to behave. Einstein predicted it long ago, that gravity can stretch time itself. The stronger the gravity, the slower time flows. And near a black hole, where gravity becomes infinite, time almost stops. At first, this would only affect the farthest regions of our solar system, space probes orbiting Neptune, the icy comets at the edges of the Oort cloud. Their signals would begin to lag. Clocks on board those distant machines would tick more slowly than those here on Earth. The difference would be tiny, a fraction of a second, then a few more, then entire minutes. For scientists watching from Earth, it would be surreal. They'd receive transmissions from probes that seemed to drift backward in time. Light from those distant machines would take longer to reach us, curved and delayed by the gravity between us. To the human eye, it might seem as though the stars themselves were slowing down. The patterns of constellations would shift sluggishly. Planetary orbits, once steady and predictable, would begin to drag, as though the solar system were moving through a thick cosmic syrup. This is what Einstein meant when he said time and space are woven together. When one bends, so does the other. On Earth, our lives would continue normally, yet subtly our sense of rhythm would change. Maybe sunsets would seem longer. Maybe music, played at the same tempo, would feel slightly slower, as though the world itself were taking deeper breaths. Even our bodies, bound by biological time, might respond. Cells would age infinitesimally slower. Clocks would disagree. And time, that old constant, would become uncertain. And while this might sound terrifying, it would not feel that way. It would feel like drifting into a dream. Because even though physics would be shifting, the change would come gently, gradually, softly enough that humanity could watch it unfold with quiet wonder. The black hole's influence would turn the night sky into a moving mural of time itself. Every distortion, every shimmer of light would be a glimpse of how gravity sculpted the flow of existence. And then, as it came closer, something even more extraordinary would happen. The light from our own sun would begin to twist, not enough to harm life, but enough to make the sky strange. During sunrise and sunset, the colors would deepen, reds more crimson, oranges more alive. The curvature of light through Earth's atmosphere would now be tangled with the black hole's distant pull. The blue of midday would feel different, cooler, darker, as though daylight itself had begun to slow, and every shadow, every glint of light on glass or water would carry a hint of the universe's slow distortion. As the black hole draws even nearer, the distortions become profound. In the night sky, some stars appear duplicated, ghostly reflections of themselves, caused by light looping around the black hole before reaching Earth. Imagine standing outside, looking up, and realizing that the stars you see are both real and echoes. Some are photons that traveled straight. Others are the same light, taking a longer, curved path through warped space-time. You would be seeing multiple versions of the same universe, layered upon itself, like a reflection in rippling water. For scientists, this would be a treasure. For poets, a revelation. It would mean that, for a brief moment, Earth could witness the universe as it truly is, a living fabric of bending light and shifting time. And in that strange reflection, something else might appear, the edge of the black hole, not the hole itself, but its boundary, would begin to reveal a faint glow, a halo of radiation, called the accretion disk. It would shimmer faintly in our telescopes, its light smeared across the spectrum, a combination of all the energy, falling inward, trapped on the threshold, between existence and oblivion. To the naked eye, it might look like a faint golden smear, a thread of starlight pulled thin across the heavens. At this stage, the very geometry of the universe will be changing around us. Distances would lose meaning. What once seemed far would appear near. Angles, directions, even the curve of Earth's orbit would subtly distort. It would be as if the cosmos itself were folding inward, softly, beautifully, inviting us into its deeper mystery. And yet, for all the strangeness, the feeling would not be one of fear. It would be awe, quiet, humbling awe, because for the first time, human eyes would see what space-time looks like when it dreams. The universe would no longer seem distant. It would seem intimate, alive and connected. Every shimmer, every slow swirl of light would whisper of something vast and eternal. And as Earth continued its gentle path toward the black hole, the distortions of light and time would remind us of a simple, beautiful truth, that reality is not rigid. It is fluid. It flows. It bends. It breathes. And somewhere beyond the limits of what we can see, it waits to show us more. It begins almost imperceptibly, far beyond Neptune's orbit, in the silent darkness where the sun's warmth fades to nothing. A gentle tug begins. It is not violent, not sudden, just a quiet, persistent pull, like the feeling of drifting ever so slightly downhill. Without realizing you've begun to move, the solar system, which for billions of years has danced to the rhythm of the sun's gravity, starts to sense another partner entering the waltz. The black hole, its gravity, unseen but irresistible, starts to reach across the void, softly at first, barely disturbing the fragile balance that has held for eons. Out beyond Pluto, comets that have slept for millions of years begin to curve in strange directions. Their frozen trails bend toward a new center, their long, icy tails glowing faintly in the darkness. The The planets, too, feel it. Tiny variations appear in their orbits, so small at first that only computers can detect them. But soon, telescopes confirm it. The rhythm of the solar system is changing. Astronomers would notice the sun itself wobbling, just slightly, as if another gravitational hand were tugging at it. The Earth, still turning, still spinning in its 24-hour rhythm, would not yet sense the danger. To the naked eye, the days and nights would continue, the seasons would pass, and life would go on. But in the silent mathematics of space, something delicate will begin to unravel. Each planet, Mercury, Venus, Earth, Mars, the gas giants and their shimmering moons, would slowly start to trace new, distorted paths. Their orbits would stretch, become slightly elliptical, each one subtly drawn toward the black hole's gravity. The solar system, once a perfect choreography of circular paths, would start to spiral, like dancers whose timing begins to slip, each one pulled toward a darker, slower rhythm. And yet, for all its danger, this cosmic shift would be breathtakingly beautiful. From Earth, nights would grow clearer, as the black holes pull slightly thins the solar wind. The sky would shimmer with a clarity never before seen. Stars sharper, the Milky Way glowing with intricate precision. Saturn's rings would catch more sunlight for a time, reflecting a golden hue that could even be glimpsed by small telescopes. Jupiter's storms would slow, their swirling colors deepening into hues of amber and violet. As energy dynamics shift within its atmosphere, it would look like the solar system was preparing for a final performance. One last, graceful waltz, before being drawn into the cosmic unknown. As the black hole draws nearer, its influence grows, not explosively, but steadily, like the rising tide that reshapes a shoreline grain by grain. The sun, the anchor of our solar system, begins to lose its dominance. Its light still shines, its warmth still reaches Earth, but its gravity is no longer the sole conductor of the cosmic dance. From the perspective of distant space probes, the entire solar system starts to drift, slowly sliding through the fabric of space, toward the invisible center of gravity. This movement would take years, perhaps decades, and during that time, the solar system's harmony will become increasingly surreal. Mercury, closest to the sun, would spiral first, its orbit bending like a ribbon caught in the wind. The planet's metal surface would gleam strangely, reflecting distorted sunlight, as both the sun's and the black hole's gravities pull it in opposite directions. Venus would follow, its thick golden clouds shimmering in unfamiliar patterns. The atmosphere, already turbulent, would become a mirror for bending light, a veil of mystery drifting closer to cosmic night. And Earth, our home, would continue to circle the sun, but the shape of that circle would change. Gradually, imperceptibly, it would become an oval, stretched toward the direction of the black hole. This change would cause subtle effects. Seasons might lengthen, daylight hours might shift, and tides could rise just slightly higher than before. Animals that navigate by magnetic fields or the stars would grow restless, confused by a sky that no longer behaves as it should. From the outer planets, the scene would be magnificent. Imagine standing on one of Jupiter's moons, perhaps Europa, looking up at a sky where both the sun and the faint outline of the black hole's accretion disk glow at opposite ends of the horizon. The light would bend around the black hole, like a halo, forming an eerie, silent ring of fire. Between them, the solar system would shimmer, planets caught between two masters, moving in a slow, spiraling waltz. Astrophysicists call this process orbital decay, but from a poetic view, it would look like a cosmic embrace, the solar system folding inward, each planet slowly circling into the darkness, with graceful inevitability. And still, time for those living on Earth would pass almost normally. People would still breathe, sleep, dream. The world would not end in chaos or flame, but in a long, drawn-out drift. Our planet would still orbit the sun until the black hole's pull grows stronger than the light that has guided us since the dawn of time. At last, a moment would come when the balance breaks. The sun, once the centerpiece of our existence, would find its gravitational hold weakening. Its fiery corona would flicker, stretched slightly by the black hole's pull. The planets, once children of the sun, would no longer orbit neatly around it. Instead, they would begin to spiral inward, not toward the sun, but toward the black hole itself. Imagine the solar system then. Mercury already gone, Venus and Earth following, Mars glowing faintly red behind them, Jupiter's moons, once the jewels of the outer system, tumbling in elongated paths, their frozen surfaces glowing softly, under the faint shimmer of gravitational light. Saturn's magnificent rings would warp, tilt, and finally disperse, each fragment of ice catching the dying sunlight before being drawn into the abyss. From a distance, if there were anyone left to observe, our solar system would look like a slow spiral of pearls, each planet glimmering one last time as it curves toward the darkness. The black hole itself would be surrounded by a radiant ring, the accretion disk, formed from matter stripped from the sun and planets. It would glow softly at first, then brighter, as friction and compression ignite the last whispers of starlight. Earth by then would be drifting quietly, its oceans rising into vapor, its atmosphere shimmering like a mirage. The continents below, bathed in dim, curved light, would look peaceful, as though the planet itself were falling asleep. For anyone still able to see the sky, the stars would appear to circle inward, as if the universe were folding itself into the black hole's center. Time would stretch, light would twist, and everything familiar would soften until even the concept of motion no longer made sense. This will be the final dance, a cosmic waltz of planets and starlight drawn together in slow, eternal rhythm. And yet, it would not feel like destruction. It would feel like completion, like the final note of a long, beautiful song, held gently in silence. The solar system, which began as a cloud of dust and fire, would return to the same, reborn within the glowing arms of the black hole's accretion disk. And perhaps, somewhere far beyond what we can imagine, the energy once contained within the sun and earth would find new form in another galaxy, another star, another world waiting to be born. The dance would end, but the music, the cosmic rhythm of creation and collapse, would go on. It happens quietly, without sound, without warning, a gentle pulling, felt first not by the senses, but by the very fabric of the world. As Earth drifts closer to the black hole, its invisible grip begins to grow stronger. Each second, each heartbeat, the force becomes more uneven, more powerful on one side of the planet than the other. This difference, this uneven tug, is what scientists call a tidal force. It's the same kind of pull the moon exerts on Earth's oceans, raising tides that roll in and out each day. But near a black hole, this effect becomes unimaginable. The nearer side of Earth, the one facing the black hole, feels a stronger pull. The far side feels slightly less. And that difference stretches a planet. At first, the change would be imperceptible, a fraction of a millimeter, barely measurable, a soft sigh in the crust of the Earth. But as gravity intensifies, the stretching grows. The planet begins to elongate. Slowly, steadily, its spherical form subtly drawn into an oval shape. To anyone on the surface, the world would still seem quiet. Skies would shimmer faintly, and oceans would rise higher at the equator, swaying gently as though under the influence of a great, invisible tide. Buildings would stand, mountains would hold, but deep beneath the crust, pressure would start to shift. Tectonic plates, which have drifted lazily for billions of years, would begin to slide faster, like dancers who suddenly hear a deeper rhythm beneath their feet. And though the planet would tremble, it would not shatter. Not yet. For a while, Earth's gravity and internal strength would resist the pull, holding its shape like a delicate thread, stretched to its limit, but not breaking. In the upper atmosphere, particles of air would start to drift upward, drawn slightly toward the black hole's direction. The sky would look thinner, the stars brighter, as air molecules scattered differently in the altered light. From space, Earth would begin to look like a teardrop, a luminous blue drop suspended in the blackness, drawn slowly toward the unseen. And somewhere in that silence, as light bends and time slows, the subtle process of spaghettification would begin. It's a strange word, coined half in humor, half in awe, but it captures something profound, because what happens next is both terrifying and beautiful. To understand what happens, when something falls into a black hole, we have to let go of ordinary logic. We must imagine a universe where gravity doesn't just pull objects together. It stretches the very fabric of matter itself. Imagine a human being floating in space, slowly descending toward the black hole. At first, they might not feel much at all, perhaps a sense of weight, a steady downward drift, a soft hum of invisible force. But as they move closer, the difference in gravity between their head and their feet begins to grow enormous. Their feet, closer to the black hole, are pulled faster, harder, while their head lags slightly behind. The result is stretching. Every muscle, every bone, every atom is drawn in one direction and compressed in all others. The person becomes thinner, longer, stretched like a strand of silk, pulled across the edge of infinity. And yet, for the falling observer, it would not feel violent. In their frame of reference, nothing would seem to change suddenly. The process would feel strangely calm, as if time itself had slowed to a deep meditative rhythm. From far away, though, to those watching from a safe distance, the scene would unfold differently. They would see the person's descent slow down more and more until it almost freezes. At the edge of the black hole's event horizon, light from their body would redden, stretching to longer wavelengths, until finally they fade from view entirely. But the stretching never stops. Even after the image disappears, the matter itself continues to elongate into a long, thin filament, a cosmic thread spiraling inward. This is spaghettification, not just the stretching of a person or a planet, but the unraveling of structure itself. Atoms that once held together in balance are drawn apart. Electrons separate from nuclei. Matter dissolves. And yet, It's not destruction in the fiery sense. There are no explosions, no bursts of sound, just silence, just light fading softly, as gravity takes hold of everything. For Earth, this process would unfold on a planetary scale. The crust would stretch first, cracking in slow motion. Mountains would flatten. Oceans would rise in long, thin tendrils of vapor, drawn upward toward the black hole's pull. Eventually, the core would elongate, its molten iron drawn into a line, a glowing ribbon of energy that spirals gracefully inward. From afar, Earth would no longer look like a sphere. It would resemble a soft spiral, a luminous filament of light and matter, curving into the black hole's dark mouth. And through all of it, there would be beauty, not fiery destruction, but a quiet surrender, a return to cosmic simplicity. Every atom that once formed our oceans, our forests, our hearts, will become part of something infinite, stretched, dissolved, yet still existing, in a new, deeper form. Now, if we slow our imagination even more and look closer, something extraordinary emerges within that stretching, within that silent unraveling. There is harmony. Physics, even here at the edge of eternity, follows rules, subtle, perfect rules that keep the cosmos balanced. As matter elongates, it releases energy, soft streams of radiation that spiral away from the event horizon. They glimmer faintly, like starlight on rippling water. This radiation, called Hawking radiation, is one of the universe's strangest gifts. It suggests that even black holes, those devourers of worlds, can emit light, can whisper energy back into the cosmos. So even as Earth is drawn in, its essence is not lost. It becomes part of that faint, gentle glow, part of the black hole's quiet conversation with the universe around it. In this way, spaghettification isn't just destruction, it's transformation. The universe is taking what was once structured, mountains, oceans, air life, and weaving it back into the deeper tapestry of creation. Think of it like music. When a note fades, its vibration doesn't disappear. It travels through the air, through memory, through the spaces between moments. It becomes part of everything else that follows. So, too with the matter that falls into a black hole. It becomes a frequency, a vibration, a part of the song that is the cosmos itself. And perhaps, if one could listen close enough, one could hear it, a hum at the edge of time, the resonance of all that has ever existed, being gently rethreaded into eternity. As the stretching reaches its end, Earth would vanish from sight, its atoms woven into long streams of light and gravity. But nothing would be wasted. No energy is ever truly lost. It only changes form. So maybe in some far corner of the universe, the energy once held within a raindrop on Earth, or within a human heartbeat, will one day emerge again, as starlight, or as the warmth of a newborn sun. That is the quiet beauty of spaghettification. It is not a scream. It is a whisper, a slow cosmic stretching that turns the physical into the eternal. It's the universe breathing in and transforming matter back into the poetry of space-time. Time, it flows quietly, carrying us from moment to moment like a river that never stops. We feel it in the ticking of a clock, the fading of daylight, the rhythm of our heartbeat. But what if that river could slow down, or even stop? Albert Einstein once imagined just that. He saw time not as a fixed beat, but as something woven into space itself, a fabric that could bend, stretch, and fold under the influence of gravity. This idea, his general theory of relativity, wasn't just a new way of seeing the cosmos. It was a revelation. It told us that space and time are not separate things, but part of one unified whole, a smooth, four-dimensional fabric called space-time. Every star, every planet, every black hole presses down on this fabric, warping it. The more massive the object, the deeper the curve. And when that curve becomes deep enough, when gravity becomes extreme, even time itself begins to slow. To understand this, imagine placing a heavy ball on a stretched rubber sheet. The ball sinks slightly, and smaller marbles placed nearby roll toward it. That's how gravity works in Einstein's view, not as a force pulling objects together, but as a bending of the fabric they move through. Now imagine making that ball infinitely heavy, so dense, so compact, that it creates an endless pit in the rubber sheet. That pit is a black hole. Near such a place, time runs differently. Clocks tick slower. Light loses energy, stretching to redder wavelengths. And from the perspective of an outside observer, anything approaching the black hole seems to move slower and slower and slower still. This is an illusion. It's reality, a direct consequence of gravity's effect on space-time. Einstein predicted this a century ago, and today, astronomers have measured it. They've seen how time slows for satellites orbiting Earth, and how light shifts when passing near massive stars. It's subtle here, mere fractions of a second, but near a black hole, the effect becomes infinite. If Earth were falling toward one, we'd begin to feel it, not in the ordinary sense. You wouldn't see clocks slowing with your eyes, but the experience of time itself would begin to stretch. Seconds would feel longer, moments would linger, reality would move like a dream. And for anyone watching from afar, Earth's descent would appear to freeze, caught forever at the edge of darkness, as though time itself had stopped. Yet for those on Earth, time would continue naturally. The heartbeat of seconds would still flow. Steady, normal, familiar. They wouldn't feel the change, because time, for every observer, always feels the same. It's only when comparing one world to another that the difference is revealed. And so begins one of nature's most haunting symphonies, where time slows not in violence, but in grace. Let's imagine Earth now drifts deeper toward the black hole. Gravity intensifies, and so too does time dilation, the gentle slowing of all processes, the lengthening of every heartbeat, every flicker of light. On the surface, people might notice something strange. The sun, for instance, would appear redder, its light stretched to longer wavelengths. As time itself begins to slow, shadows would lengthen softly. Sound might seem slower, though that would be perception, not physics. The clocks would still tick, the wind would still blow. But if you could compare your watch to one on a distant spacecraft, you'd see it. Their minutes would pass faster than yours. Their time would race ahead, while yours stretched languidly, like honey dripping through air. This is the beauty of relativity. There's no universal clock, no absolute now. Everywhere in the universe, time flows at its own rhythm, guided by gravity and motion. If someone watched Earth's journey from a safe distance, say, orbiting far from the black hole, they would see Earth slow down gradually, at first imperceptibly, then noticeably, then almost frozen, just before crossing the event horizon. For them, it would look like time had stopped. The last radio signals from Earth would stretch longer and longer, each pulse taking more time to arrive, each photon of light growing redder, until finally, silence. But for Earth's inhabitants, nothing would seem strange. Time would continue normally. They would see the black hole growing larger in the sky, light bending around it like liquid glass. They would feel no sudden stop, no pause, no shudder of physics. In their world, life would still move forward, smooth, slow, calm, as the rest of the universe seemed to speed away. It's as if the universe itself were pulling gently on the threads of time, stretching them thinner until moments lose their sharpness and begin to blur into one another. That's what time near a black hole feels like. Not chaos, but calm. Not a scream, but a deep, endless exhale. And perhaps that's the secret beauty of Einstein's prediction. He showed that time is not rigid or cruel. It's soft, flexible, alive. It can slow down. It can bend. It can cradle entire worlds in its gentle arms. Now, imagine standing on Earth, just moments before crossing the event horizon. The stars above would seem frozen, their light hanging motionless in the sky. Colors would deepen, turning red, then black. Even the concept of before and after would begin to blur. You could lift your hand and see it move, but the motion would feel slower, as though the air itself had thickened. Each breath would linger longer, each sound stretched softer, until silence enveloped everything. This is time dilation. At its most extreme, the edge between existence and eternity. Einstein's equations predict that as you approach the black hole, time for you continues smoothly. But for the outside universe, you never quite fall in. You appear suspended, forever hovering at the edge, your final moment stretched infinitely long. This creates a haunting paradox. To you, you cross the horizon in seconds. To the universe, you never do. You become eternal light, frozen at the brink. This is the true poetry of relativity. That time is not one river, but many, each flowing at its own pace, each defined by its own gravity. And so as Earth falls, it enters a deep, slow current. Seconds stretch into centuries, centuries into eternity. The rest of the cosmos appears to race forward. Stars are born and die. Galaxies collide and fade, while Earth drifts, unmoving, silent, caught in its own private rhythm of time. Yet inside, life still moves. Atoms still vibrate. Hearts still beat. It is a calm so deep, it feels like peace. Einstein called this not a trick of perception, but a law of nature, the universe's way of balancing speed and gravity, energy and time. To fall into a black hole is to fall into slowness, to drift into a place where the past, present, and future merge softly into one. Perhaps beyond that horizon, time no longer flows at all. Perhaps it becomes something else, a stillness so profound that eternity itself feels asleep. And in that quiet truth, we glimpse Einstein's greatest gift, the idea that time, the thing that carries us all, is not rigid, not mechanical, but alive, responsive, and deeply beautiful. Imagine a place where light itself cannot escape, a place where even time surrenders, and every law of nature softly fades into mystery. This place is called the event horizon. It is not a wall, nor a solid surface. It's simply a boundary, the invisible edge surrounding a black hole, marking the point beyond which escape is impossible. If you were falling toward a black hole, you wouldn't see it as a sudden barrier. There'd be no flash, no explosion, no sound, just silence, a deep, endless quiet. You would drift closer, watching the blackness swell before you, its curves shimmering faintly, with twisted light from the stars behind it. Around the edges, you'd see something beautiful, a bright halo of distorted starlight, circling the black hole like a glowing ring. That glowing edge is the last light struggling to escape. It bends, wraps, and dances around the darkness, forming what astronomers call the photon sphere, a place where light orbits the black hole, trapped in endless circles, never quite falling in, never quite getting out. And just below that lies the event horizon itself, the ultimate border. Crossing it is not like crossing a finish line. It's more like crossing a horizon at sea. Nothing changes at that moment, yet everything changes forever. Einstein's equations predict that once something crosses this horizon, no information can return, no signal, no particle, no whisper of what happens inside. From the outside universe's perspective, whatever falls in is gone. But for the traveler, for the one falling, it's different. They experience no sudden stop, no violent crash. They simply drift deeper into gravity's embrace. Time continues, but differently. They would feel as though they're still moving, still alive, still conscious, while the universe outside appears to speed away, faster and faster, until all that remains is a soft, steady pull of darkness. This is the silent horizon, a boundary not of fire or noise, but of calm inevitability, a one-way passage into the unknown. And yet, there's something strangely peaceful about it, because the horizon is not destruction, it's transition. It is the place where the universe whispers. Beyond this point, you are part of something greater. Let's imagine Earth falling slowly toward this boundary. From space, the black hole would now fill the sky. Its edge, a ring of swirling light and energy, would glow with quiet intensity. Around it, the stars would appear to bend, their positions distorted by the immense gravity. Everything would seem to move slower. Time itself would thicken as Earth drifts closer. The light from our planet reaches observers farther away, but it takes longer to escape. Each second of light stretches, turning red, then infrared, then invisible, until finally the last whisper of Earth's image freezes at the edge to a distant observer. Earth never truly falls in. It appears frozen in time, locked forever at the horizon, its final glow fading slowly, for eternity. But from Earth's point of view, we cross that boundary without hesitation. We don't notice the exact moment. There's no jolt, no flicker of light, no signal saying, "You have crossed." We simply drift in. It feels like passing into deep sleep. You can't tell when it begins. You just realize softly that you are somewhere else. The light behind us fades. The stars disappear. Only the blackness ahead remains. Inside this region, the pull of gravity becomes absolute. Every direction now leads inward. There's no way back, no sideways escape. Space itself is curved so completely that forward always means deeper, It's hard to imagine such a place, not because it's chaotic, but because it's so quiet. There are no flames here, no explosions, no roar of destruction, only the calm, the unbroken darkness, and the soft hum of inevitability. In this silence, we find a strange kind of peace. Perhaps it feels like floating through endless night, like drifting in a dream, where time has stopped caring about beginnings or endings. Perhaps it feels like surrender, not fear, not pain, just acceptance. The event horizon, for all its mystery, might not be the end. It may simply be the beginning of another kind of existence, one where the rules we know fade away and something deeper takes their place. From the outside, the story looks different. The universe watches Earth's descent, but never sees it complete. For all of time, the planet appears to linger, half immersed in shadow, its final image stretched across infinity. This creates one of the most haunting ideas in science, that black holes preserve a memory of what falls into them. Even though matter disappears inside, its information, its light, its imprint, seems to stay frozen at the horizon. This puzzle is known as the information paradox. Physicists like Stephen Hawking spent decades wondering whether the universe truly forgets. What crosses that line? Some say the information remains encoded in a thin layer of space around the horizon, whispering faintly in patterns of energy and heat. Others believe it's lost forever, woven into the unknown interior, where space and time collapse together. Either way, the horizon becomes a storyteller, a silent record keeper of everything that's ever fallen in. Imagine it, the ghosts of stars, the remnants of planets, the memories of civilizations long gone, all resting quietly in the curvature of space-time. It's poetic to think that nothing is ever truly lost, that even as the Earth disappears, its pattern, its essence, remains somewhere invisible yet real. Perhaps that's why astronomers call it the point of no return, with both awe and reverence, because this is where science meets silence, where the known fades into the unknowable, and where imagination becomes the only light that can still travel beyond. In truth, the event horizon is not an ending, it's a mirror. It reflects the limits of human understanding, showing us where knowledge stops and wonder begins. To cross it, even in thought, is to step beyond time, beyond sight, beyond fear. It is to accept that some mysteries are meant not to be solved, but felt, and in that quiet surrender, there's something peaceful. The silence of the horizon isn't empty. It's full of meaning, full of promise, full of the soft hum of eternity itself. Imagine for a moment that you are falling through the heart of a black hole. You've crossed the event horizon, and now space itself is guiding you inward. But this is a fall of fear or speed. It's a fall through stillness. There's no air rushing past, no sense of motion, just drifting, just surrender. The deeper you go, the stranger reality becomes. Space curves around you in ways that no human mind can truly picture. Every direction leads inward. There's no up, no down, no past or future. Only now, only this gentle descent into the heart of gravity's secret. And yet, you are not being torn apart instantly. At first, everything feels calm. The deeper regions of a massive black hole are vast, so large that you could fall for hours days, even weeks, before reaching what scientists call the singularity, the point where gravity becomes infinite and the known laws of physics dissolve. No one knows exactly what happens there. It's a question that has whispered through physics for decades. Some believe that the singularity marks an end, the final compression of matter, the quiet vanishing of everything that was. But others see something far more beautiful. They imagine that the singularity is not destruction, but transformation, that the matter falling in, the energy, the light, the memories of stars and worlds are not erased, but rewritten. Perhaps, they say, each black hole is the seed of something new, a womb hidden inside darkness, from which another universe might someday be born. It's a poetic thought. That, what we call the end, is simply another beginning. And as you fall deeper, as time stretches infinitely long, perhaps you wouldn't even notice that rebirth beginning. Perhaps you would feel only peace, a soft, endless drifting through a silence that hums faintly with the echoes of creation. To understand this gentle rebirth, let's imagine how nature behaves, even in her darkest moments. When a star dies, it doesn't vanish. Its outer layers drift away into space, becoming nebulae, vast clouds of glowing gas and dust. And in time, from those clouds, new stars are born. Destruction, it seems, is never truly destruction. It's a recycling, a transformation from one state to another. The same may be true for black holes, according to some theories, like loop quantum gravity and white hole cosmology. The collapse of matter in a black hole could eventually rebound, creating a burst of new space-time. In that model, a black hole could give birth to what we would see as another Big Bang, a new universe with its own time, its own physics, its own possibilities. So, if Earth were ever pulled into a black hole, our atoms, our oceans, our mountains, even our stories, might one day reappear elsewhere, reassembled, reawakened, as part of something brand new. Maybe in that new universe, our starlight shines again, our oceans rise under foreign suns, and our atoms help form new worlds, where life someday opens its eyes and wonders where it came from. It's a comforting idea, isn't it? That the universe never wastes, that even in darkness, there's a promise of renewal. Stephen Hawking once said that black holes ain't as black as they are painted. He discovered that they slowly leak energy, a faint glow of radiation that escapes their grasp. This Hawking radiation means that even black holes eventually fade away, releasing their energy back into the cosmos. So, in the grandest scale, even the black hole dies softly. It evaporates, its energy spreading across eternity, nourishing the universe like the ashes of a burnt star that fertilize the next generation of suns. The cycle never truly ends. And maybe that's the universe's way of saying that everything changes, but nothing is lost, that every ending is a beginning in disguise. So, perhaps Earth's final journey through the black hole is not a vanishing, but a merging, a gentle return to the same cosmic sea that gave us birth. Now, imagine that everything has gone quiet. There's no starlight, no motion, no thought of time. Yet, somehow, in that infinite calm, you sense something profound, the soft vibration of existence itself. It's as though the universe is breathing, and you are part of that breath. In this place beyond the horizon, You are no longer separate from the cosmos. You are its memory, its energy, its continuation. Perhaps your atoms scatter as light in another world. Perhaps your essence becomes a whisper in the birth of a new star. Or maybe you dissolve entirely, not as loss, but as unity. You become part of everything. And isn't that, in a way, the most peaceful outcome of all? Science, for all its equations, finds beauty in this mystery, because every answer we discover leads not to closure, but to deeper awe. Even if we never truly see inside a black hole, the thought of it reminds us how vast and connected existence really is. Every moment we live, every breath we take, is a ripple in the same cosmic fabric that curves and folds and gives rise to galaxies. Perhaps when we imagine Earth's fall into a black hole, what we're really imagining is a return to the source of everything, a homecoming to the place where energy rests, and matter dreams of stars yet unborn. The peace beyond the black hole isn't death. It's silence. It's balance. It's the universe closing one chapter and quietly beginning another. And so, as we float here, past time, past gravity, past light, we find not terror, but tranquility. The black hole, in its deepest truth, is not the universe's destroyer, but its painter, brushing darkness across the canvas so that light can shine again. It teaches us that even the end of worlds can be beautiful, and even the collapse of stars can create new beginnings. And in that understanding, there is peace. So, if ever you look at the night sky and feel small beneath its infinite depth, remember, you are part of it. Your atoms, your thoughts, your life are echoes of stars that once fell into the same gentle darkness. Everything that ends returns. Everything that fades becomes light again. And that is the peace beyond the black hole. Thank you for drifting through this cosmic dream with me tonight. May your sleep be deep, your heart calm, and your dreams filled with wonder and light. Good night and goodbye.